Okay, so sorry for the pause in the beginning, but for some reason the sound doesn't kick on until 6 seconds of activity, so that's why I waited a while there. This is a classic looking geometric series here, right? So the divergence theorem could apply, and we'll do that in a minute. First thing I want to do is this just looks like I'm multiplying each term by e over 2 or something like that. So you don't have to do this piece right here. I usually find the first term just in the event I need to do this formula here, which I'm not going to, but usually that's what I do. So I plug in 0. That's going to be e over 2 to the negative 1. And then I plug in 1. I get e over 2 to the 0. And then I get e over 2 to the first, and that's a first. And then I get e over 2 squared. So this is 2 over e, which is weird. I get 1. I get e over 2. I get e squared over 4. Clearly, it looks like I'm multiplying from here to here. I'm multiplying by e over 2. Here, I'm multiplying by e over 2. Oh, actually, I'm doing the same thing here. I'm multiplying by e over 2, right? So 2 over e times e over 2. It's going to cancel out. It's just going to give you 1, right? So this feels like it's geometric. The question is, how is my r too big? So if you don't remember, I do because I'm a nerd. E is equal to 2.718 yada, yada, yada. Oh, e over 2 is bigger than 1, right? So there's my r. So therefore, my series, so you don't even need to write that. As long as I see this statement here, you don't need to write this stuff up here. This is just helpful. As long as I see r is greater than or equal to 1, usually the absolute value, but there's really no negative here, so it doesn't really matter, is bigger than 1, I can write down divergent series by geometric. So I look for that word, that expression right there, all set. You could have used the divergence theorem. Why is that? Well, because the limit as n goes to infinity of e to the 2 over n minus 1, this number here is bigger than 1, so any number bigger than 1 to infinity is going to be quite large, right? It's not going to be equal to 0. So what you could have done is just say is not equal to 0, diverges by divergent theorem / test. I don't really know which word goes there. I don't really care. Or you could write down nth test. And hopefully that makes sense to you, that if the last term, right, I'm looking at the last term as n goes to infinity, if the last term is not equal to 0, that means all the terms before it are probably going to be bigger than whatever this last term is, which in this case is infinity. And if I have to add up an infinite number of terms where the last term is not 0, the sum is obviously going to explode, right? And we'll talk about that again in another problem. So to me, this problem looks geometric. However, either one of these models would have worked. Whatever one makes you happy. Again, what am I looking for here? Diverges by the divergence theorem or nth term test, and that you found the limit for me. Okay, don't just write down doesn't equal 0. Tell me what the limit's equal to. This is kind of weird that the limit's equal to infinity. Usually when you use a divergence theorem, the limit is equal to some nice number like a half or 2 or 1 or something like that. Some non-zero value. Okay, so that's in a problem number 1.